I bet I know why y'all struggled with number 3. You gotta change it to what? This is x to the negative 1. So dy dx, whoa, negative 1 x to the negative 2. Power rule, right? Plus 5, what's the derivative of sine?
Oh, hold up. Cosine. But by the way,
Yes.
the solutions, when they do the product rule, they like do it backwards.
They do.
And so like some of my answers were freaking me out because they were right, they would be like flip.
So they do
They'd be like flip.
first times derivative of the second plus. It always makes more sense to me to go in with the derivative of the first, just because that's how I learned it, and that's how I teach y'all. If that confuses y'all, you're welcome to do it the other way.
I did like on number 9, my answer just flipped. It's like
I definitely thought she was fixing to talk about this problem.
Ask a real question. Ms. McGee, may I ask a real question about that real quick?
Yeah.
How did you go from negative 1 to negative 2 to negative 1 over squared?
Okay, so remember, in the bottom means negative exponent, right? So I bring it around front and I subtract 1.
Camden used to be honestly lit, and now it's just gotten.
But like I'm talking to the bottom.
Okay, so negative exponents come around to the bottom of the fraction and become positive.
Yeah.
So think about those
Well, think about how you started the first one. You started the first one by bringing x up to x up to negative 1. So
if I had that, the x would stay up top, but the y would go to the bottom and become positive. It's just the backwards of what we did here.
Except for there,
They understood this one.
I just need to know that
You can, every negative exponent, you can always move and make it positive. 15. 9 and 15. Ooh, look at number 9.
Yeah, so I got it, and this one might but it's right there.
This is quotient. How do we do? Derivative of the top. What is the derivative of cotangent?
Negative cosine.
Derivative of the top
But they did this though.
times the bottom minus the top times the derivative of the bottom. Again, same derivative. I bet they didn't do it backwards. I bet.
And then you cancel your cosine. It's annoying. Okay.
Okay, no.
Just for the just to say this, I hate how with the quotient rule you have to take up 2 lines. I would almost just like to work out the time.
You can.
When you do one line,
I know y'all can relate to that. You have to take it like twice as many.
No, because the derivative of 1 is 0.
The bottom you just read it.
So if I'm in a FRQ situation, I'm good here, right? But if I'm in a multiple choice question scenario, I need to be able to manipulate this a little bit and see. On an FRQ, yeah, but this would definitely be a multiple choice type question. And they would give you, and what they're probably going to do is test to make sure not only do you know how to find the derivative here, but you understand what cotangent, cosecant, and all of that is, and how you can clean this up a little bit, if we can even clean it up. So let me show you what I would do here. You can. This is negative cosecant squared x minus cotangent is the same thing as what?
That would be a cosine over sine.
Cosine over sine. And what is cosecant?
1 over sine, right?
Ew, this isn't going to clean up any.
You don't do all that.
Okay. So this would be cosecant squared x cotangent. Oh, I see what you're saying. Plus cosecant squared x cotangent x. There's many times you do have to do that.
See, the cosecants do cancel.
Yeah.
You have one left, and your cosecants cancel. Oh, you're right. Okay, there you go.
You can cross out one of those.
Negative cosecant squared x over 1 plus cotangent x squared.
Yes, that's my No. There's more. No, there's nothing more that you could do. You couldn't get cosecant. Okay, so I had that, and then I looked at the solution to see if it was right, and they went further, and they did 1 over
Sine squared
sine
times
squared x times 1 plus cosine squared x.
cotangent squared. The only thing that I could see here doing would be this times 1 plus cotangent x squared. I would definitely not take it.
It's 1 plus cosine squared. That's what they did in the 1 plus cosine squared. Yeah, that's right.
I don't have the answer for this one in front of me. I would not take it any further than that unless you're in a position where that answer is not one of the choices, in which case you might start doing what I was getting ready to do up here, where I start manipulating some of them and multiplying out.
I don't ever know how.
My rule of thumb is whenever everything is factored down, you're pretty much done. Like you couldn't factor it or do anything else there that way. Here, because this is factored, I would leave it there, wouldn't go any further. Unless you're in a multiple choice situation again where you don't see your answer. All right, which other one? 24. We didn't have 15.
No, do 21. Start off. Can you start off with 24 and show me how to write the equation?
With what? 21. Find equations for the lines that are tangent and normal to the graph of y equals sine x plus 3 at x equals pi. So the first thing I need to know is tangent. This would be the slope of y prime, right? Normal would be what? So it's right.
That's what I was saying.
So we're going to take this and we're going to, I don't know what that is.
That's the easy part.
All right, so let's find the derivative. Derivative of y equals sine x plus 3 is cosine x. If I do that at pi, what's the cosine of?
At pi, you plug it. Cosine of pi is you plug it into the first equation.
To find a point, yes, but right now I'm finding the slope.
The slope of the tan line?
-1. So the slope of the tan line is, what's the slope of the normal line?
So what do you do?
1.
What do you mean? I'm struggling to understand why.
Opposite reciprocal.
Oh, -1?
Yes.
So 1 over 1.
Flip it, change the sign.
So 1 over 1. On the bottom, so you do 1 over 1 on the bottom. Like you would plug that into the opposite.
Second?
So you have 1 over 1 over 1.
Yes, well, -1 is like -1 over 1. So when I flip it,
Yeah.
and I change the sign.
I'm trying to write what is all 1.
Okay, so if I had 2/3, the negative reciprocal to that would be -3 over 2. Or if I
plug that into the bottom.
what you plugging in? No, this is just slope right now. That's just slope. I need the point at pi, so I need y of pi, right?
You got that 1 right here. I thought that had to be.
Sine pi plus 3. What's the sine of pi? 0. So this is just 3. So what I'm doing is I'm writing two equations of two lines. I'm writing the equation through the point pi 3 with a slope of -1. And I'm writing the equation of the line through the point pi 3 with a slope of 1.
Wait, if sine of pi is 0.
Sine of pi is 0.
When you say opposite reciprocal, that's just the negative.
Yes. And I don't usually say negative because if it's already negative, it'll become positive.
And that's just, so that's like, you use that when you get the derivative slope to find the normal slope.
Yes. Let me write this equation down. There's the tan line. Point slope form. Point slope. Point slope.
Don't tell me what I can and can't do.
Oh, B is non-calculator.
There's no way you couldn't on 23. It's got.
Oh, come on, Dylan. Let me show you. Oh.
Wait, so you don't have to plug it.
Oh, because it's x equals 3. You're right. Yes. Just use the unit circle. Do y'all need me to do that one or not?
I really don't.
Okay. 24. Okay. Use the definition. Oh. I wasn't going to make you derive any of the basic ones. I didn't realize. We want to prove. They said they didn't need it. Do you need me to do it?
We don't need it. We can do it after this. Do 25.
All right. What's the definition of the derivative? That's the first question. Okay. How am I? But what's the formal definition? Before you knew how to. The difference question.
I'm so sick and tired.
The limit is h goes to 0 of f of x plus h minus f of x all over. I know. All right, my f of x is cosine x. Do we agree?
No, why is that?
What?
Why do we agree? How do we just assume that cosine x is the f?
That's what it told us. It told us to use the definition of a derivative.
How do we know? Oh, Wally?
This one is.
All right, so like, what now? Where do you plug in negative sine? That's the derivative of cosine x.
So don't you do cosine x plus cosine h?
No, me.
We're gonna move right along for this one. I'm okay with having you derive the cofunctions and the secants and all of that, but I think that sine and cosine and tangent, you are not going to further your understanding of how to use trig derivatives by deriving that. You are not. It's okay. Rather than bog down in that, let's move.
I wrote yeet on my face.
20 what? Okay, this one does help you in your manipulation of trig functions. All right, so we're going to use the fact that the derivative of sine is cosine, and we're going to use the fact that the derivative of cosine is negative sine, and we're going to prove. Didn't we do A? Oh, okay, I apologize. So what we want to do is we want to show that the derivative, and this one we're not going to use limit quotient on. We're just going to do quotient property. Tangent of x is the same thing as what? Sine over cosine. So let's do quotient property here and do the derivative. Derivative of the top. Are y'all confused? I just rewrote tangent as sine over cosine. Yes. Cosine times the bottom minus the top times derivative of the bottom over the bottom squared. I feel like we did do this one yesterday, y'all. Okay. Cosine squared plus sine squared, which should make you stop and go, wait, that's 1. So I get 1 over cosine squared, which we of course know to be.
Oh, so how do you prove that secant x equals secant x?
That one was so clean. Like, don't you just go one of those?
It is. It's very satisfying, isn't it?
It makes sense.
I agree. You want me to do part B? Okay. Part B, derivative of secant x is secant x tangent x. So this one, secant x is the same thing as 1 over cosine. So derivative of 1 over cosine, again, I could use that quotient property if I wanted to. You have to do it because you don't know the chain rule yet. I think next year I'm teaching chain rule before I get into this. Derivative of the top is 0, right? So it doesn't matter what this is. Minus the top times derivative of the bottom, negative sine over the bottom squared. It doesn't matter what this is because it's multiplied by 0. It's going to be 0. Derivative of 1 is 0. Yes. So this is negative times a negative. So this is sine x over cosine squared x. Remember, we know where it's going, right? It's going here. So I'm going to split this up into sine x over cosine x times 1 over cosine x. Again, because I know where I'm heading. I know what I'm trying to prove. This is tan. This is secant, which of course I could rewrite the other way because multiplication is commutative, and I would have shown that the derivative of secant x is secant x. Well, what I was telling you is these are good. These are good to know because if you don't memorize them and you get in the position on the test where you need it, they're easy to derive. So I see the benefit in deriving these.
Like last time, I said no, my homework like.
Yeah, we have a separate ice maker because our ice maker doesn't keep up. Before people that all want big cups of ice in the morning, it doesn't make enough ice. So. My ice maker, my fridge, yeah. So we bought a separate one. Yeah. Oh.
Okay, how was it?
Y'all's attention span is shorter than my second and third block's attention span. 27. All right, remember those parent graphs that I said you just need to know? Here we are. So secant x is 1 over what?
1 over sine.
Cosine. I'm going to show you if you don't remember the secant and cosecant and cotangent functions, what we can kind of do here.
What are you supposed to do, right?
All right. So you're showing that they have horizontal tangents at x equals 0.
Right.
Now, that means that I better have a what at x equals 0? What? How do you have a horizontal asymptote?
When you have
If I'm looking at a graph, Y'all just name. I'm just gonna say words I know I've heard in here before.
Derivative constant,
Wait, you're gonna get there in a minute.
Zero in the denominator is vertical.
How do you ensure on the graph, or how do you tell on the graph of the regular function if you're gonna have a horizontal asymptote? When is the slope 0?
when the denominator is set to 0.
When is the derivative gonna equal 0 on a graph?
When it's
What did you say?
the horizontal. When the top is heavier than the bottom. Or maximum.
At maxes or min.
That was your
Extrema. Exactly right. That's where the direction is changing. I stop increasing and I start decreasing. That's where I'm at rest right there, right? I stop doing this. That's right. So I'm looking for a max or a min happening at 0. If that happens, then yes, I know there's a horizontal change that does that.
So can we get the derivatives in these?
Okay. So because it said that I have to show it graphically, I can't show it. If I could show it with the derivative, that would be easy. I'd just find the derivative of each one at 0, right?
Wait, so you found the derivative instead of the derivative?
I'd find the derivative at 0, and the derivative at 0 should be 0. But it didn't tell me to do that. It said show that the graphs have horizontal tangents. So I just need to sketch the graph and show that they have a max or a min at 0.
What's secant again?
Okay, what is secant? That's 1 over cosine. So first thing is, where is that undefined? That's undefined everywhere cosine is 0. Where all is cosine 0?
Let me think.
At pi over 2. Cosine. So where is there no x value there? At the top and the bottom, right?
Yeah.
So that's pi over 2. What's at the bottom?
I haven't looked at that thing in a minute.
OMG. 3 pi over 2.
I haven't looked at the unit circle in that.
I'm just going to do this middle quadrant here. At 0. At 0 here, what is the secant of 0? This is a non-calculator.
You can do the negatives too.
I can go that way negative. All right. What is secant of 0? It's 1. Why is it 1?
Secant of 0?
Oh my gosh.
Why is it 0?
Maybe 1 over 0.
Cosine is 1.
No, they didn't do 1. They did 1 over 1.
Right. Yes.
Wait.
So why'd you? I thought you said 0. I got it.
But anything times 0 is 0. What are you talking about?
So what is the secant of 0?
So would you recommend before the AP exam?
Yes,
Right.
absolutely learn that unit circle.
Right when it starts though, should I just like draw the whole unit circle out?
No, you should just know it so you don't waste time.
Maybe
Isn't that the right answer?
It's-
Shut you.
How do you know it goes up there?
If you're not worried about why things happen and you do just want to do that, at least learn the little trick there is to writing it out super fast. There's something about going by 1, 2, 3, something, and then backwards. There's some little trick right there. All right, because I know what secant looks like. The closer I get to pi over 2, look at your graph. Look at your unit circle. The closer, as you move from 0 to pi over 2, is the cosine value getting bigger or smaller? So think about x. Look at that. It's getting smaller. So if it's getting smaller, but it's on the bottom of a fraction, then this is getting bigger. If this gets small and you flip, then it's really getting big. So that's why it's going up towards infinity here. Yes. Yes.
My problem with all of this calculus is, usually in math, there's steps to do everything. In calculus, it's just like
Intuitive.
you gotta wing that. It's not fair. It's not fair.
No, it is. It is,
Because
man.
I could look at this
Stop.
problem and then I would just be like,
I feel like you're setting me up to tell me you're not going to do this.
I I'm not saying that. I'm just saying that if I would look at this problem and be like, okay, I gotta find the derivative of C next, and that's all I would do. I would not know any of this graph.
Well, the only reason I'm doing the graph is because
It says show that the graphs of y equals.
otherwise, I'm with you, Van. I would do the
Well,
derivative.
you know, he didn't pass kindergarten.
All right, look. Do you see the minimum here?
Sure, let's do cosine.
That's how I know there's a horizontal tangent.
Yeah.
Same thing with cosine.
These problems just screwed me last night.
What's the cosine of 0? And so we know that the graph of cosine looks like this. And look what happens here again. That's how I should. It's a maximum.
This is stupid.
Tell us how you really feel.
I don't like it.
I know, I'm sorry. Yes.
Forget it, whatever.
28. Don't pay him any attention. Oh, another graph.
I'm gonna just copy what you did.
Tangent x. What's the tangent of 0?
Tangent of 0 was 0.
Does it go up this way or down this way?
It goes, well, I don't even know what tangent is.
That's
the one that goes up to the right and down to the left.
Yeah, side. It goes something like that.
And it would continue doing this.
Okay, y equals 10.
You're the only one.
My feet are sweating.
What? Y'all are so. Squirrel! Why does this have no horizontal tangent?
Well, that's because it's just
It's never 0. The slope is never 0.
It does not. Alright, it doesn't have any max or mins.
It's just like a horizontal.
It doesn't have any maxes or mins. Horizontal tangent would be the slope of the derivative
The
of
slope is
0.
never, like, it never switches from a positive.
This, right. This has a horizontal tangent here because it has a max or min. This one has none.
That poor particle is never resting.
It's not. It's just going forever and ever and ever.
So like,
Okay.
when it says, show that the graphs of y equals tangent x and y equals cosine x have no horizontal tangents, what if we show that this graph has none? We can't get the other one. But since we show that this one does, then it answers the question. It said and.
It didn't say or.
Yeah, it said and.
I know. And means show both. Or
I
means
know,
show
like the way
one.
I'm thinking about it is like, if one of them's not the other one,
That's not necessarily true.
what if they said it?
But the cotangent looks very similar to this one. It shifted over in the other way, and so yes, you said the same thing. All right, are y'all ready?
The problem is that we keep doing questions that are like the exact same. Like 2 or 5 times.
Let me just set up 30 for you, and then we're going to move on. All right, so y equals tan x, but this says it's from negative pi over 2 to pi over 2. Parallel to the line y equals 2x, so all you're going to do, parallel means same slope. What's the slope of this line? 2. So what I need to do is I need to do the derivative here. What's the derivative of tangent?
It's like, no, sorry, I'm sorry.
Come on. Secant squared x. So I need to know where is 2 equal to secant squared x. Bam. All right, and then I would solve that. I'm going to take a break for just a second and let y'all get all your squirrel jokes out. Is this a calculator or non-calculator?
No calculator.
No calculator. So where is 2? 1 over cosine squared. I'm going to say this would be a calculator problem.
That's weird.
For here, they mark a lot of them that should be not, that are not. No, but you have to find,
Don't you need to find the derivative of that?
already did the derivative.
Oh, no, can't you again though? Of course you can.
But I don't want to do it again. I just want to know where it's 2.
All right, jerk.
So far, we've done position.
So basically, jerk is when the object starts moving from one point, right?
This is kind of like a very sudden change in acceleration.
Exactly. When it
You get whiplash.
That's exact. I have that written on my notes. Whiplash. Yes.
so like
Yes. Yes. A very sudden change in right.
like a sudden change.
It's like you're walking.
Wait, so would you just figure that out by seeing when the velocity changes really fast, like abruptly?
Acceleration.
Acceleration.
Mhm.
So when it just drops to zero and then goes back up.
Mhm. Second derivative is acceleration. Now we have a third derivative. So the focus here to, yeah, yep.
What if it's a function where you can't the third derivative? There be a jerk or
Then
not?
there's no jerk. All right. So this is going to be some more practice with our particle motion. Let's start. Let's start with 34. 34 says,
What does it say to the left?
Well, I'm not sure, like, if y'all knew that.
Jerk. What's wrong?
I don't even know what y'all are talking about.
I'm not.
So basically, let me put it this way. So if you're on a roller coaster, right? Whenever it starts all of a sudden, it starts going faster, and then it
Boom.
gradually goes.
Right.
Never heard this. Okay, well, we don't all want it in our head.
All right, y'all got that? This is number 34 on page 152. I don't know why it's been kind of glitching out.
Okay, I need to scan my.
All right. In the following problem, a body is moving in simple harmonic motion. Okay, so that's just like a particle motion problem. Okay, don't get caught up in those words. With position, S equals F of T. S is in meters. T is in seconds. I'm reading this just straight from the book. Part A. And it says 34 says S equals sine T. I decided to do the plus cosine. What is what? It's a function. It's just saying that it's a function.
S equals sine plus cosine.
Mm-hmm. So it says part A, find the body's velocity, speed, acceleration, and jerk at time t.
Yeah, that was. Yeah, no, it's not. Very derivative somewhere.
If you open it in Canvas first, and then you go to the bottom and click it, it should allow you to submit it that way.
You have to share it as a copy. That's what I do. It's like
it's not too hard.
Okay. So I know that S is sine t plus cosine t. Correct. So first thing I'm going to do is velocity. What is velocity here?
It'd be cosine plus negative sine t.
Cosine t minus sine t. That is easy, yes? What is the speed?
Well, it'd be cosine t plus sine t.
You can't just do that. No, you can't. It doesn't. No, because some places sine is positive or negative, and some places cosine is positive. So you can't just change the sign in front of that.
No.
Just put the absolute value signs there. You just literally take velocity and put absolute value signs around it. Yeah. That's it. That's it.
It's actually numbers. All right, now let's do.
What do you mean?
Let's do acceleration now.
How about acceleration? It does. So that's what simple harmonic motion means. Is as you keep going, it is an oscillation. That's exactly what it is.
All right, well, let's keep.
So acceleration, and that's the point of this problem, is that you see that. All right. Negative sine t minus cosine t. How about jerk?
Well, that's really easy. All our questions are like that.
Yes. So now for part B, it asks you to find all of these values. It says find the body's velocity, speed, acceleration, jerk at time t equals pi over 4. So that's exactly right, Allison. I'm just going to plug pi over 4 in for all of these. So velocity yes. These are both the same value. The over 4s is the easiest one to do, so we're glad they gave us those because that has the same value for sine and cosine.
Is that for everything or just?
That's velocity.
That's for everything.
I mean, like all that speed equals cosine t minus.
That's part A.
That's, yeah.
No, that'd be
Negative square root of 2 over 2. Minus
2.
Square root of 2 over 2.
Those are 1.
It's just square root of 2. Yeah, negative square root of 2, right? That'd be negative 2 square root of 2 over 2. The 2's would cancel.
It would turn into square root of 4 over 2, which would be 2 over 2.
What are you talking about? This one? This one, they're exactly the same. So if you subtract anything from itself, it's 0. Okay. You're done. Yes, it is. That's exactly right. Good job, Van.
I'm like way behind everybody. No, it's okay.
That's okay. But the fact that even though you still made that connection, that's okay. All right, speed. What's the speed here? Absolute value of 0. I'm not going to go back through all that because I've already done it one time. Why did you do that? Make sure you put units. I'm sorry I didn't do that. Meters per second, meters per second. Yes. Because speed is the absolute value of velocity. Always. Meters per second per second.
There's like no way.
Yes. Yes. You can do meters per second.
There's no way. There's no acceleration, no speed.
Is there no acceleration? Negative sine of pi over 4 minus cosine of pi over 4, right?
Well, it's not moving. If there's no velocity, how could there be acceleration? You're going 0 if you're going fast.
What's the sine of pi over 4? Meters per second squared. This would be there's 2 of those. When in doubt, unit circle. Just say unit circle. It's the answer to everything in
Why do
calculus.
you do the little 2 thing right there?
Because this is 1 and 1.
Yeah, that's 1. Let's do that.
What is -1 minus 1
Oh, yeah.
over the same denominator?
3.
They're like terms. Jerk.
Or maybe there's 2.
Negative square root of 2 plus square root of 2.
Right so fast.
I'm sorry.
Trying to keep up.
Meters per second cubed is meters per second squared per second.
Taking up on the phone.
Part C.
I'm just kidding. I'm like half.
Describe the motion of the body. Okay, yes, but it's oscillate at 0, at time 0. What's happening?
What?
What? Because I'm wondering if it wants the motion now or
What's the motion? Oh, really? How did you know that? Right. What did you say?
if you're wondering about what this looks like, if you look on page 149, there's a picture of a weight and a spring, a weighted spring. That if you think about the weight being on the end of the spring and you drop it and it goes and it starts going boom, 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 boom. That's what this is kind of doing. That's harmonic motion.
So what do you?
So I think here it's enough to say that it's oscillating here between the values. That is the motion.
Well, they didn't say explain why.
Yeah, they didn't say why. They just said describe. So I would just say that it's oscillating. Yes, yes. You want me to write that? No, no. Ooh, let's see if you can do this. This is number 39.
Wait, what questions were down for our homework?
Well, these are in that loop.
Oh.
I don't know because I think I'm gonna cut some of these out.
I hope so. Can you give homework tasks for people that are in the class?
Find the 725th derivative of sine x. Find the 725th derivative.
Hey, it'll end up going
Why?
to 0.
It keeps flipping around, but how often does it flip around? That's the question. So if I do the first derivative, it's what? I'm gonna just do what's the derivative of sine? Cosine. What's the second derivative? Well, we're gonna look. What's the second derivative? What's the third derivative? What's the fourth derivative? How many does it take to whip back around to where I started? 4. So 725 divided by 4 would be what?
It'd be 181.
So 181 times, right? But how many are left? What's 181 times 4? No, there's some left over.
Yeah, there's one. There's one. So back.
To number 1.
Yeah. Wow.
You see what I'm saying? If it repeats every 4, 725 divided by 4.
Okay, so how do you know? How do you know 4?
Because I just did all the iterations and look, it comes back to Sine X where I started. What imaginary number? So 181 times 4 was 724. Is that right? So there was a remainder of 1, which tells me go to the first iteration.
Okay, I mean 1 I squared.
That's yes. That's the same thing.
Yeah, let's go ahead and do 38 then.
Try it, because that's one of your homeworks. 38 is the 999th derivative of cosine x. So I started finding the derivatives to find when it would repeat. Okay, so there are 4 iterations of sine. It goes cosine, negative cosine, sine, and it keeps repeating. So I divided this by 4 to find out where I would be. In other words, if I just kept counting through until I got to 725, this is where I would end up. Yes. Aaliyah jumped way ahead. 38 asks you to do, go ahead, cosine x. Because you had this 1 left over. Others of you are starting to freak out a little bit because you're going, oh my gosh, how are y'all doing that fast? What is going on? Y'all are doing witchcraft in here. If this repeats, no, it's positive. It flips around on the 4th one. That's exactly right. The iterations repeat on the 4th. So if you divide 999 by 4, what do you get? Look, 4 goes into 999, so that would be 2. 19 would be 4. But what's left over? What's your remainder here? 3. So you go to the 3rd. But these iterations are different because the first one here is negative sine x, and then it's cosine x. I mean, negative cosine x. Me? That was clown here. Why'd you do that?
What did I do?
I don't know. You hit something.
You're sitting here. Your foot is a little.
No. It had that screen capture in it. Did you hit that?
You're writing my stuff.
A minute ago.
No.
You just did it by itself?
Like literally 10 seconds ago. Didn't do it a minute ago.
Okay. So I go to the 3rd because that remainder was 3 left over. Y'all didn't learn iterations in pre-cal?
No, seriously, I did.
I taught it in Algebra 2 1 year. I didn't teach it every year. I taught it 1 year. Yeah.
I learned like what the unit circle was and not any other value.
For part of your homework tonight, I am going to have you really be describing in sentences what's going on. So I'm going to do one more with you, and then I'm all done. This is number 12. That's the iteration you go to. Yeah.
And that's just something stupid. We're going to keep going with derivatives for a long time.
No, I'm not on this.
Just throw it all. Let's just go ahead and take those 18. I feel like I'm
I think tomorrow we might do, well, but I wanted to do those FRQs tomorrow too.
Wait, Mr. D,
If it's Freaky Friday, I'm aware of nothing.
when it gets closer to like maybe, are you gonna like change it to people now because of FRP?
Yeah.
Like now I know like we can say, oh, this is FRP. Like,
You understand if he's down, he hasn't
He told me he wasn't gonna